Have you ever seen text like this? Or opened a page and found someone's name turned into symbols and question marks? That isn't random. It usually means the computer got the character encoding wrong. And once that happens, text stops being text and starts being noise. Why should you care? Because this is not just a cosmetic bug. Broken encoding can make content unreadable, make data hard to search, confuse forms and URLs, and cause systems to process text incorrectly. Humans read characters. Computers store bytes. A character encoding is the rulebook that maps between the bytes inside the computer and the characters you mean to represent. Think of it as the key for decoding text. With the right key, the bytes become meaningful characters. With the wrong key, the same bytes turn into garbage. This is where people often get confused. So here's the clean distinction. Unicode is the big universal catalog of characters. It gives characters identities called code points. UTF-8 is an encoding, one way of turning those Unicode characters into bytes. The same Unicode character can be encoded in different ways, such as UTF-8, UTF-16, or UTF-32. On the web, UTF-8 is the standard default choice. Here's why encoding matters. A byte is just a number. The meaning depends on the encoding. In older encodings, the same byte value could mean completely different characters. Unicode fixed the which character is this problem by giving characters stable identities. But you still need an encoding, like UTF-8, to turn those identities into bytes. In UTF-8, ASCII characters use 1 byte, while many other characters use 2, 3, or 4. One more important distinction. Encoding is not a font. Encoding tells the computer what character the bytes mean. A font tells it how that character should look. If the encoding is wrong, the system picks the wrong character before the font even gets involved. So what should you do in practice? The short answer is, use UTF-8 everywhere you can. Save your files as UTF-8. Declare UTF-8 in your HTML. Keep your database, API, and exported files consistent. And test with multilingual content. Character encoding problems often stay invisible until real users show up with real names, real languages, and real data. So, to sum up, character encodings are what let computers turn raw bytes into actual text. We covered what they are, why text breaks when the raw encoding is used, how Unicode provides the shared character repertoire, and how UTF-8 encodes that text for the web.